So now let's build the algorithm. So here I am replacing it as linear equation. All right, I mean linear regression. So now I'll just write the steps of the linear regression, guys. I mean, how do you build the algorithm and all? So the first step is to import the libraries. Second step is to read the data set. Third step is to apply reprocessing. Fourth step, if you want to do any analysis, you can do analysis like visual representation and all. Fifth step is to train the algorithm. Sixth step is to test the algorithm. Seventh step is to find the accuracy. Eighth step is to random value predictions. All right, guys. So these are all the things that we have to do while creating an algorithm or writing an algorithm. So everyone knows till here. So you know how to do visualization and all. So pre-processing also you know, right? So now let's get started how we have to complete this. All right. So before going that, let's see what is the data set that I have given to you. So what is the data set that I've given to you guys? Can you please open? So here I have given a data set called salary underscore data, right? So in the example, I've mentioned the example as salary and experience, right? So in the same way here also, we have a data set which has experience as well as salary. So a person who is having 1.1 experience will have 39343 as his salary, 1000. This is in thousands. So 1.3 experience has 446,205 salary. So like that, it has the experience till 10.5, something like that. Yes or no? Yes. So now let's apply linear regression algorithm to this data set. So let's get started with the practical programming. So the first step is to import the libraries. Here the libraries that I am importing are import import pandas as Ph.D, import numpy as NP. So everyone done with this step? Guys, let's move a bit fast, please. Yes, the next one is to read the data set. So first of all, you have to go to the path where your salary underscore data is. Copy the path and paste it over here. Yes, I've read the data set. Now, what's the next step? That is data pre-processing. So in the data pre-processing, what is the step after the reading the data set? Handling the missing values. Yes. So how do you handle the missing values? First of all, you have to check whether there are any missing values or not. Do you have any missing values here? No. So no need of handling the missing values. Now, is there any need of label encoding and one-hot encoding over here? So do we need to apply anything? No, because we don't have any string data. So directly you can split the data into X and Y. So what is the X values that I have to take here? Tell me. So till splitting of data, you do it, guys. I'll just give 5 minutes of time. As you already know the data pre-processing, just do it. Guys, do it and tell me. Just 5 minutes time for you. So X is 0 is to 1 and Y is 1 is to 2. Once this is done, then you directly should split the data into X train and Y train. Train underscore test underscore split X underscore Y underscore test is equal to train underscore test underscore split of X comma Y comma test underscore size is equal to 0.2 comma random underscore state is equal to 0. So I've done with my X train also. Now let's see the shape of that X train dot shape is 24 rows and 1 column, and Y underscore train dot shape, it will also have 24 columns and 24 rows and 1 column. Now let's build the algorithm. So we have completed, and for regression guys, you don't need to apply feature scaling. I'll tell you why we don't need to apply feature scaling while I explain about the classification algorithms. All right. So my pre-processing is done. Now the next thing is train the algorithm. So whatever the theory I've said before, that will be taken care by the module itself. So let's see what is that module which is used for training the linear regression. All right. So we have a package called linear model. Import linear regression. So for this linear regression, I have to call the instance. So what I'm doing is I'm just putting it as regressor is equal to linear regression. Now you have to train the algorithm. So what are the variables that are used for training, guys? So what are the variables that are used for training, and what are the variables which are used for testing? Guys, what are the variables used for training and what are the variables used for testing? Guys, are you understanding the classes? Are you following the classes or not? Only 2-3 of you will respond to me. I don't know. X underscore train, comma, Y underscore train. So the training are X train and Y train. So whatever the theory that I have said, that will be taken care by this instance, linear regression. So we are passing the arguments to this, which are X train and Y train. All right, it's not X and Y, guys. It is X train and Y train. Why will X and Y are used for training? While data pre-processing itself, I said X train and Y train are for training. Tests are for testing, and Y test is used for as a key value. Didn't I tell you? Yes. Regressor dot fit guys. Regressor dot fit of X train, comma Y train. Yes. Now my algorithm got trained. So let's see whether my model is predicting the values correct or not. So for that, I have to put a test to this. So what is the test I'll put? I'll just put it as regressor dot predict of X underscore test. So I told you X underscore test is the questions which will be given in the exam, right? So this I am putting it as pred or Y pred. Y underscore pred is equal to regressor dot predict X underscore test. So let's see what are all the values that are there in X underscore test. So here I am giving 1.5 years of experience, 10.3 years of experience, 4.51 years of experience, 3.1 years of experience, 9.1 years of experience, 8.7 years of experience, row by row for the prediction. So whenever it passed 1.5 as your variable, then the value to that particular one will be stored in the array of ypred. So let's see y test as well. If you see this, For years 1.5, the experience is for years 1.5 of experience, the salary would be 37,731. For 10 years, the salary would be 1,22,391. For 4 years, the salary would be 57,081. So this is X test and these are the key paper. Now let's see whether Y-pred and Y-test are similar or not. So this linear regression, it should not be obvious that both the values should be exactly same. There can be some sort of difference. So let's see whether Y-pred is same or not. So yeah, so my algorithm predicted as, for 1.5 years of experience, my algorithm predicted the salary as 40,748. So there is no very huge difference between 40,000 and 37,000. All right. So if you see the answers, they are approximately equal. So except this is having a huge difference, but remaining everything are same. Did you see the difference, guys? Did you see the difference, guys? So we have completed till testing the algorithm. So I have trained the algorithm with my train and test, and I have tested the algorithm. Now let's see the accuracy. So how do you get the marks of a test? You will be comparing your answers as well as your key paper. Yes or no? So based on that, you will be getting the marks. In the same way, the accuracy also should be given between your prediction as well as the key paper. So for creating the accuracy, you have a library called, so I'll tell you this, what is this accuracy, what is the backend mathematics of accuracy while I am dealing with the metrics, evaluation metrics, okay? But for now, just see the program. Y underscore test comma Y underscore spread. Now call the accuracy. So the accuracy is 98%. So your algorithm is fine for the future use. So it is direct, it can directly predict the other values as well. Done till here, guys? Shall I wait for some time or shall I proceed? The next step is to find the random value predictions. So whenever you see this prediction, you are giving the whole number of rows together. X underscore test of rows together, yes or no? But I would like to just predict only for the 1 year that I give. So at that time, what you do is yp is equal to regressor dot predict of, in double array, just give the any value that you want. Now I give it as 12 years. Execute this. This should be double array, guys. So here you have to pass the number of columns that are there in the data set. So if suppose if you see x train, x underscore train or x underscore test, how many columns do you have? Only one column, which is years of experience. Yes or no? So you have to only pass the years of experience. Right? Now I have calculated my y of p. Now y underscore p will be sorry, YP will be 1,38,531. So if you see the data set, do you have 12 years of experience in the data set? It only have 1.1, 1.3, 1.5, 2, 2.2, 2.9, 3, 3.2, something like that. Yes or no? But here I am giving it as 12 years. Based on the best equation that it got created, it is predicting the years. Now you can also give any number of years. So 20 years, it is 2 lakhs. 100 years, it is something like 9 lakhs. Or again, you just give 1 year, it gives something like 30,000 or so. Right? So this is what random value prediction is. Understood till here, guys? So whenever you give only single bracket, over here, then you get a error called 1D expected 2D array but got only one dimensional array. So in order to make that as 2 dimension, you have to give 2 square brackets. Right. And why am I sending only one value if suppose I give another value comma 2? It says input operand has a mismatch in this 4 dimensions. So in linear regression, we have one column for input and other column for output. So you have trained only value 1 in a column. If you give 2 columns, it gives an error that you have trained only on one value, but 2 values have given. So that's the reason based on the columns that are there in your X-train, those many columns are to be given here. You will understand this once we are doing it with the multilinear regression. So this is what your linear regression is about. And let's plot a basic graph for this. So let's see how our best fit line is formed. So for that, what I am doing is import matplotlib.pyplot as plt. Matplotlib.pyplot as plt. Then here plot dot scatter of x underscore train comma y underscore train, x underscore train comma y underscore train comma color is equal to red. Now after this I wanna plot the best fit line. So for that plot dot plot comma x underscore train comma regressor dot predict of x underscore train. So just execute this plot dot show. So can you see this? Can you see this? So in the paint that I've showed you, so if I actually close the paint. So before that, what I have plotted x, that is 1, 2, 3, 4, 5. and y also like 1, 2, 3, 4, 5. So I have plotted my actual values, yes, and also some predicted values. Did you remember? And I've drawn a line of equation here, yes. So that is what here also I am doing. So here first I am plotting the values between x train and y train as a scatter plot. So first I have plotted a graph between x train, that is x and y actual. X and y actual as the plots. And then I am plotting the graph between x underscore train comma predicted values. So here the values I have got from the points that I have substituted from x only, right? So y is equal to 1 into some equation. So that also x into y pred only, right? This is y pred only, right? So here also I am using the same regressor.predict. So I am predicting the x train. I am sending the values for the prediction and then I am plotting a line. So did you understand this graph now? This is what linear regression is. So this is the best fit line that is being created. This is not the initial line that is created, guys. It is the final line after the error minimum is calculated. All right. So this is what all about linear regression is. Understood, guys? Understood? Yes or no? Yes. Now, shall we move on to the multilinear regression then? So the same thing happens, guys. The same thing again, whatever the steps that we have written here, those will be followed for the multilinear regression as well. All right. But the data set that I've given is different. So here I'm just taking a new Python file, naming it as multilinear. So before going to multilinear, let's see what is the data set that I have given. So now look at the data set and tell me what are we trying to do. Look at the data set and tell me what are we trying to do. What is the data set about and what are we trying to do? I find only Shivakumar is there in the class. No one is responding for my questions. Yes. So here we have different attributes of a company. So a company is spending some amount of like 1,65,349 rupees on research and development and administration spent, and the amount on administration and the amount on marketing, and the company is from New York, is earning a profit of 1,92,261 rupees. Let's suppose this is a daily profit of a company. Let's suppose, so if a company is having these values, then the profit of that particular company with that values are 192261. So like that, you have number of observations for each and every company from different kinds of states. So for this multilinear regression, I would like to predict the profit of a startup company based on the observations which are showcased over here. All right. So did you understand what the data set is? Here we are predicting the profit of a company. So now let's go to the program and let's do the data pre-processing first before applying the algorithm. All right, guys, do the data pre-processing before applying the algorithm. So I want you guys to do till that. I don't want to explain anything about it. You guys do it. I just go with my own flow. So it's your work to complete till data pre-processing, right? So I'm doing it. Let's see who will do fast, guys. It's 12:14. So let's see who will do fast and who will give me the answer. Let's have a competition between you and me. Are you doing it, guys? Do it. Let's see who will do fast. Do we need to do label encoding and one hot encoding for this, guys? No need of label encoding. You have to do it. We have state, right? You got the accuracy in negative. Try changing the random state and do it, ma'am. Guys, I'm doing very slowly. Let's see who will be ahead of me. Who has done till here? It's a competition between you and me, guys. So guys, who have completed till here? None? None, guys? Only Madhavi ma'am. Students from you. Do it, guys. Do it fast. 2 minutes. Fine. So now what I did is, first I've imported the libraries. That's really good. And then I have read the data set. I've imported the libraries. I have read the data set. And I've checked whether there are any null values or not. There are no null values. So I went for label encoding of the state. So once I'm done with the label encoding, if you see, my label encoding has been done. So in the state, I have three categorical values. One is New York, Florida, and California. Based on the alphabetical order, these numbers are given to the state. Once that is done, then I've done the splitting of data. So here I'm considering the first four rows as my input. So that's the reason I've given it as 0, 1, 2, 3. If you want to grab 3, then you have to give the 4 as the end slicing rate. That's the reason I've given it as 0 is to 4. In the same way, I want y as my profit. So 4 is to 5. So I have defined my inputs as well as outputs. Good. Once that is done, then what I am doing, I am applying the one hot encoding. So where am I supposed to apply one hot encoding? The state column is in the third column. So that's the reason I've given it as 3 is to 4. So those one hot inputted values are being stored in Z. After that, as I already have state column, I would like to remove it. So the column number of state is 3. So that's the reason I've removed it. Once that is done, then I'm concatenating my X with Z. Yes. So this is how my data set with one hot encoded values have been created. Now if you want to just check X, so if you see here, first three values are one hot encoded values. So first three values are one hot encoded values, and then remaining are 1, 2, 3 are, this is R&D spend, this is administration spend, and this is marketing spend with other three columns. So if you see X dot share, you have 50 rows and 6 columns, out of which 3 are for our binary data of state. 3 are for binary data of state. Once that is done, I have done the splitting of my data. So I've completed my splitting of the data into X train, Y train, X test, and Y test. So once this is done, the next step is to train the algorithm. So as the functionality of multilinear regression and the linear regression are same, for multilinear also I can use the linear regression function, I mean the instance or the package. So I am directly using it as linear regression. So after that, I'm just putting it as MLR, multilinear regression is equal to, I'm just calling the instance of a linear regression where whatever the theory I've sent, whatever theory I've shown, I've explained you, that will be taken place. So here for this MLR, I'm passing the data fit of X underscore train, comma Y underscore train. Right, X underscore train and Y underscore train. So I am training my data with all the 6 columns with output column. So once this is done, sorry guys, this is X underscore train, comma X underscore test, comma Y underscore train, comma Y underscore test. I'll just execute this. Yes, my multilinear regression has been trained. Now we have to test the data. Before testing, I'll see what are all the rows that my X test has. So my X test has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. So you are sending row by row and you are predicting the values. So for this respective X test, the Y test values are 103282. So if suppose the country is from, so one is New York, country is from New York and it is spending 6,60,515 on administration spend, 1.8 lakhs on marketing and 1.18 on R&D. The profit of the company would be 10328. So these are the actual values. Now let's see the predicted values of it. So for that, what I do, y underscore pred is equal to model dot predict of x underscore test. It's not model, it's MLR. I gave the name as MLR, right? If you see, my model name I gave as MLR. So wherever you give MLR, wherever you are calling the functions of the model, you have to call it with the name itself. Now just execute this y underscore pred. Now let's see y underscore pred. If you see, some approximately equal 10 0 3 0 1 5 10 0 3 2 1 5. Yes, have you seen this? They are approximately equal. So now let's see the accuracy of it. How do you see the accuracy from? I'll just first execute this case and then I'll give time for you for execution. Okay, sklearn dot metrics import r2 underscore score. So accuracy is equal to r2 underscore score of y underscore test comma y underscore pred. Now call the accuracy. It is 93%. So Madhavi ma'am, I don't know why you've got minus values. Guys, first suppose if you are getting the less accuracy, then the hyper tuning parameter is your random state number. So you can give any number here. Change the number to 42 and let's see whether how the accuracy is being changed. So whenever I am changing the number, the accuracy is reduced. So for my model, 0 is the best set. 0 is the best set. So you can see I got 93 as the value, right? So once this done, then I have to do the random prediction. So here how many columns we have? 6 columns. First 3 columns are states, binary values of states. Then next 3 columns are R&D spend, administration spend, marketing spend, right? So for that, what I am doing is yp is equal to mlr dot predict in double array. I want to send the city is California 1 comma 0 comma 0 comma marketing spend is administration spend is something like 1 2 3 4 5 6. Administration spend is something like 3 4 5 6 7. R&D is something like 8 9 6 7 5 4. Just execute this, see the YP, then you can see the profit of that particular company will be 1,72,010. So this is how I built the multilinear regression. There is no difference between linear regression and multilinear regression coding except the columns that you are used for prediction and the number of columns that are there for training, right? So just execute till here, then I'll show you the other part. Yes, I'm explaining the last step. So here I am giving the random values. Yes or no? So now what are all the columns that we have trained our algorithm with? State, state, market, R&D spend, administration spend, marketing spend, and administration spend, right? So these are the values that I have to give. Okay. So if you see x underscore train, so first three values are binary values of the state. First three values are binary values of the state. Next one is the marketing spend. Next one is the administration, and then you have R&D, right? So in the same manner, you have to give. So here you are giving directly all the rows together, but I don't want all the rows together. I just want to see the random predictions of a single state. So at that time, I'll give the state random state binary values. So 100 is nothing but California, right? So California state is spending some amount on R&D, amount on administration, and amount on some marketing spend, and I'm giving these values for prediction. Whenever your model would get, whenever your model predicts, you get a YP. I mean, you get the answer. So a company having these values as the spent values, then here you are getting the profit of a company. Srijana, what are we doing now? Is this not the profit of a company? The main aim is to predict the profit only, right? Is this not the profit? Then what are you what, I hope people, you guys are not understanding the basic, right? This is what we got, right? So this is the output. We have trained the data with output, so the output will be profit only. Okay, fine. So now you have to plot the graph, but this multilinear regression should have 3D dimensions or 4D dimensions to plot. So likewise, we have plotted for linear regression. We can plot it for multilinear, but you can plot the graph between x1 and y, x2 and y, x3 and y. So let's see how do we plot it. From what? So first three columns are binary values only, right? So I want to plot the graph between the marketing spend as well as the profit. So what I give the column of the marketing, I mean, this is not marketing, the R&D spend is 0, 1, 2, 3, third column, right? Third column, comma, y underscore train. So you can see the data between your marketing spend and y train as the linear line. Now if you want to plot dot scatter of you can see there is some zigzag line which is not a linear line, but if you want to see that in a hyperplane, then that will be a hyperplane, then you should have a 4D dimension. So if you see the data, the plot between